Okay, so this video is going to be dealing with confidence intervals. Now before we get started, it is quite important that you are familiar with normal distributions, as well with z-scores. If you are not, I recommend you can watch plenty of YouTube videos and do other sorts of things. Just use your own methods to determine what those are. But you need to be familiar with normal distributions and z-scores. So I'm going to assume that you are familiar with them. And let's get started. So first off, I should probably note something. So in order to actually use confidence intervals, you're going to need your sample to be normally distributed. Okay, so your sample needs to be normally distributed, which means if you were to plot your sample out using, it would look like this, right? Now, if your population is already, let's say your population is also normally distributed and it looks like this. If this was your population, then if you took a sample of that population, it's also automatically going to be normally distributed, which means it's also going to be looking the same like that. Now, if your population doesn't look like this, let's say your population looked like this kind of, and it was rightly skewed. Notice that it's sort of going towards the right. So this is a problem. We can't actually do it unless we take a large enough sample size. Taking a large sample size of a population that's not normally distributed is called the central limit theorem. Basically, that means just exactly what I said. It's nothing too complicating. So if the population was rightly skewed, it's not normally distributed. If you take a simple random sample, so if you just take a random sample from this population and you plot that data, and if you take a large enough sample, it turns out that it will be normally distributed. So that's the thing. So it's quite important that if you're dealing with a population that's not normally distributed, you have to use a large enough sample to make your actual sample normally distributed, because that is a necessity. But if your population is already normally distributed, like over here, then you don't have to do anything and your sample's automatically going to be normally distributed. So now that that's out of the way, let's get started here. Okay, so suppose 25 students are selected at random to find out their score on an exam. Their average turns out to be 68%. The standard deviation is 6 for all students in the population. Find the 90% confidence interval for the population. Okay, so another thing you're going to be needing in order to actually solve confidence interval problems is the standard deviation. So you're going to need your population, your sample size rather, your sample needs to be normally distributed, and you need the standard deviation. So first off, how is a confidence interval denoted? Because we need to know how to answer the question. Well, there are two popular ways of actually denoting this. There's x. As the name suggests, a confidence interval is between two values. It's a range. So it's between this value and this value. Or you can write it like, since we're dealing with a mean here, 68% plus or minus the margin of error. So the error on how wrong this value is. Now, the purpose of a confidence interval, which is probably what I should have mentioned initially, is to determine how wrong or how off you are, how off the sample is from the population, based on some characteristic. Now, the characteristic we are using here is the mean, so the population mean and the sample mean. The purpose of the confidence interval here is to find out how wrong or how off the sample's mean is from the population's mean. That's it. That's all we're trying to find out. In order to figure that out, we're using some sort of range. So we're saying the sample's mean, which is 68%, is off by some range, and as a result, the population's mean is probably falling within that range somewhere. So let me elaborate first off on what this is up here. That's going to be 68% subtract the error and 68% add the error. That's going to be the interval. Oops, that kind of went off screen there. Okay. Oops. So that's essentially two popular denotions of what we can use. I'm going to be using both of them just to show you a bit more on how to do this in various ways. So our first step is going to be to calculate the margin of error, how wrong our mean is from the sample mean. And we do that using a formula. So the error, I'm going to say the error is equal to the standard deviation divided by the square root of the sample size. Okay? So first off, I should also mention that the standard deviation here, which is also denoted as sigma, so in case you forgot, sigma is also the standard deviation. Okay? So it's also quite important to note that this is the standard deviation of the population, not of the sample. See, it says the standard deviation is 6 for all students in the population. So you need to be using the standard deviation of population and not of the sample. Now, I also forgot you have to do this multiply z. I thought I wrote that down. So this is the standard deviation of the population, n is the sample size, and z is going to be essentially the confidence level, which is in this problem 90%. But it's going to be if you know about normal distributions, which I'm assuming you do, then you know you can use the standard probability table to determine standardized values for certain proportions on a normal distribution. So when you're dealing with a proportion that's like, let's say 90%, let me change color. So we're dealing with something that's 0.9. If we were to look on the standard normal probability table, you would find an associated standardized value. That's also called a z-score. Now it turns out, if we were to actually use a table and look at what the value would be, it's going to be equal to 1.645. 1.645. Now that we know the z-score, or the confidence interval, the next step is just to plug in the data. So what is the let me change color. No, okay, let's just change color. So what is the standard deviation? Well, it's 6 divided by, what is n? Well, it's going to be the sample size, which we have as 25. So 25. And it's going to be multiply the z value, which is basically the confidence interval, but the associated z value of it, which we found was 1.645. So 1.645. And mind you, what we're doing right now is calculating the margin of error. We're trying to find out how off our mean is, the sample mean, from the population's mean. So all we're doing here is calculating how wrong the sample is from the population. So if you were to actually do this calculation, it turns out to be 1.974. Let me draw that in a bit more. 1.97. Oh, sorry, did I say put a 5 there for some reason? Let me just do that over. It's 1.974. Okay. So we know the margin of error. So this is also the error. The error of this is how wrong our sample is from the population. I really want to drill that in. So let me just take this and move it off to the side to make some more room. Okay, so the next step is to actually answer the question in a formal manner, because this is only a partial answer to the question. So, as I mentioned initially, there are two ways of denoting how to actually answer confidence interval problems. You can either do XX, or you can do the whatever value you're trying to do. In this case, it's mean, so it's going to be the mean plus or minus the error. So let's first off do the initial way, the one on top, the XX value. So it's going to be 68% subtract the value we got from the error that we calculated down here, 1.974, comma 68% add 1.974. And if you were to actually do the subtraction here, you would get 66.026, comma 69.974. So what this says here is that the population mean falls within these two values. It's between these two values. So another way to write this is 66%. So 66% plus or minus 1.974. So these are two ways we can write our answer, the end answer for this value, or for this problem rather. But if you want to answer it formally, which you might be asked on a test, you would have to answer it like so. Let me get rid of all that. So let me change color to blue. So you would have to say something like, you have to say with 90% confidence. With 90% confidence, the mean of the population is, then we would give one of these interval notations that we used. Let's say we want to use the bottom one just because it's smaller. 66% plus or minus 1.974. So with 90% confidence, we can say that the mean of the population is between the sample means 66% plus or minus these values. Or just say the mean of the population is between 66% plus or minus 1.974. So essentially this is how you would formally answer a confidence interval problem. Now, an important note here is that we're trying to find confidence, so we're not using anything with probability. So we're not saying that 90% of the time the mean is between these two values. That's different from what we're writing down here. What we're trying to find is the confidence level, the confidence interval. The difference between a confidence interval and probability is a probability determines the future events. One half would be the probability of getting heads on a future coin toss, right? But what we're doing here, we're using data that's already been collected. So there is no probability occurring here. We're saying with 90% confidence, the mean of the population is between some values. We're not saying that there's a 90% probability that it's between the values. We're saying that there's a 90% chance, or not chance, but rather we're confident at around a level of 90% that the mean is between these two values. There is a distinction between them. So you can think of it as saying 90% is how sure we are that the mean of the population falls between two values. It's not probability. Just keep that in mind. That can be a common misconception when you're trying to answer these kinds of problems on tests or quizzes, and they would result in getting the answer wrong. It's a big no-no. Think of it like this. Let's say there was a 50% chance of shooting a basketball and having it go inside a hoop. So there's a 50% chance of when you throw the basketball, it's going to go inside the hoop. But that's a probability, right? But what we're dealing with here is a confidence level. So in this case, it would be like saying the basketball went in 50%, which is just ridiculous. The basketball can't go in just 50%, right? So that's the difference here. Probability states future events, but confidence intervals are the results of those events. Because whether your probability is 50%, the end result of it is going to be whether the basketball goes in or not. It can only go in, yes, or it can miss. Those are the only results. So hopefully this helped. I might be making more videos on this topic. There is a lot more, well, not a lot more, but there is some more information to go over regarding confidence intervals. So if you have any questions, be sure to ask in the comment section below and I'll do my best to answer them. And have a nice day.